Good morning, class. So sorry that I cannot be in the class with you this morning because of the delay on my flight. And so please go through the syllabus on the Canvas and register for my math lab through BibliU. Yeah, and also please review the video today, and so it will be very important. And since the spring semester is typically tight, so we do not want to waste one day of time, okay? And so on Wednesday, we will continue with 1.2. And this class is a linear algebra class, and so today we will, do the system of the linear equations, and which is the first section of the linear algebra, okay? So let's look at the definition. What is a linear equation? Linear equation in the variables x1 dot xn. Yeah, so sorry, I think when it converted to PDF, and it's not converted right. Yeah, so it's x1 dot xn is the equation that can be written as a1 x1 plus a2 x2 plus an xn equal to b, where b, a1, an's are real or complex numbers. They are typically called what? Coefficient. Yeah. So what is the most important thing for the linear equation? Your x1, x2, xn, the power of these variables can only be what? 1. If you have x1 squared, that is not linear anymore. If you have 1 over x1, that is not linear anymore. Are you with me? 1x over x1, no. x1, x2 squared, no. Square root of x3, no. Yeah, so you have to have the power equal to what? 1. And a system of linear equations is what? A collection of one or more linear equations involving the same variables. Yeah, so we can have two. We in algebra we also learned like a linear system, like 2x plus y equal to 3, 3x plus y equal to 5. Are you guys with me? So this will be the easiest linear equation that we use to learn. Okay, and what is a solution? A solution means we wanted to find x, y such that both of the equations works. So a solution for a linear system, it may be more than 2, maybe n of them. Yeah, so we find the list of the n tuples, and such that when we substitute the n equations, every equation holds. Yeah, so this is called the solution. And the set of all possible solutions is called what? The solution set of the linear system. And two linear solutions are called what? Equivalent, if they have the same solution set. Yeah, you guys remember, for like a system of linear equations, yeah, it has what? No solution. Do you guys know, like in algebra, what means no solution? In 2 dimension, easy example. 2 dimension means only x and y. Yeah, what means no solution? Parallel. Are you guys with me? Yeah, so parallel lines means no solution. Exactly one solution means what? They intersect. And infinity many solution means what? They are identical. Yeah, so but this is only for 2 dimension. So now if you take two pens or 2 pencils, yeah, and in 3, our space is what? 3 dimension. Yeah, and so you put one pencil above the other one. What did you see? Make it, do not intersect them, and do not make it parallel. Do they intersect? No. Yeah, and do they parallel? No. Are you guys with me? So what does this tell you? It has no solution, but it does not need always to be what? Parallel. So like in the future, we will discuss more questions like this in 3 dimension, and or in n dimensions. Okay, so it does not always need to be parallel. This is the biggest difference between what? low dimensional like we learned in algebra, and high dimension that we learned in linear algebra. Okay. And so we call it a system to be consistent if it has one solution or infinite many solutions. And a system is said to be inconsistent if no solutions. Okay, remember these two definitions: consistent and inconsistent. Inconsistent means no solutions. And the other essence of information of linear system is what we wanted to record compactly in electoral array called matrix. Do you guys, I believe that you guys learn a little bit matrix definitions in pre-calculus, yeah? And for the system, the equations, yeah, so we wanted to, the matrix made by all the coefficient, we call it coefficient matrix. So these are the coefficient of all the variables. Like for the first row is 1, -2, 1. Yeah, so this is where we have 1, -2, 1. And the second row, what is the x1? The coefficient of x1 is 0, yeah? So, if there is nothing, it's 0. This is why you have 0 to -8, -4, 5, 9. So this matrix is called coefficient matrix. And if we have the extra, column 0, 8, -9, if we add this column, what do we call this? We give another name. It's called augmented matrix. Augmented matrix. Okay, and augmented matrix means if you add the extra column here. You guys with me? You add the extra column here. Okay, so so you guys, I just put these two definitions in one, yeah, so you guys know what is the thing. For the coefficient matrix, is only the coefficient, and if we include the constant on the right side, it's called augmented matrix. And the size of matrix is always, we always use the number of rows and columns to define the size of the matrix. Yeah, so for example, for this matrix, what is the size of this augmented matrix? How many rows do we have here? We have 3 rows. We have 4 columns. So we call this matrix to be a 3 by 4 matrix. And then similarly, for the coefficient matrix here, it will be 3 by 3. Are you guys okay? So this is 3 by 3, 3 by 4. Okay, and the basic strategy to solving the linear system, in algebra, typically what are the methods we use to solve the linear system? Elimination and substitution, yeah? So, like these are the 2 methods, yeah, that we have, yeah? So, and here we wanted to review, and we wanted to connect the elimination method and with the thing that we learned here, with the matrix thing that we learned here. Okay, so now let's go over this question. Yeah, so for the elimination method, so when we have this question, this in algebra, and what will be the first variable you wanted to eliminate? So for your second equation, you only have x2, x3. So which one do you want to eliminate? Most likely eliminate x1. Yeah, how could we eliminate x1? What will we do? We can use equation 1 times 4 and with equation 3. Are you guys with me? Equation, so that all the x1s, if you add them together, it will become, yeah, so equation 1 times 4 and equation 3, and then you will get a new equation 3. This is the new equation 3. Are you with me? So the new equation 3, which will have what happens here? It means what? No x3, no x1 anymore. Yeah, so we only have what? X2 and x3. Yeah, so the new equation we only have x2 and x3 here. Yeah, so then this means x1 is gone. Then we can use what? Equation 2 and 3 to solve. Are you guys with me? So now let's look at what will be the corresponding matrix. Yeah, augmented matrix. We use rule 1, in order to simplify, use R1, rule 3, R3, rule 2, R2. Yeah, okay. So what did we do? Is we wanted to use what? Equation 1 times 4 plus equation 3 give you the new equation 3. So what will we do? We will do the same thing for the rule. So use rule 1 times what? 4 plus what? R3. So your equation 1 become rule 1. Your equation 3 become R3. Are you guys with me? So it's exactly the same. So rule 1 times 4 plus R3, it will be the new R3. Yeah, so what will be the corresponding new matrix? What will be the corresponding new matrix? What happened? Your 1 times 4, this will be 0. Are you with me? Negative 2 times 4 plus 5. Negative 8 plus 5 is what? Negative 3. It's exactly the number here. Are you with me? So 1 times 4, or 1 times 4 plus what? 9. 1 times 4 plus 9, which will be 13. 0 times 4 plus negative 9, that's still negative 9. So what will be the new matrix? This. Are you guys with me? So what will be this new rule? That is what you get from here. Are you guys with me? So wow, magic, yeah. So this is what you exactly get from here. Yeah, okay. So negative 3, 13, negative 9, and x1, there is no x1. So this is this. Are you guys with me? So what do we really want here? We wanted what? X1s. For the second two equations, no x1s. And then similarly, and how could we get, now we have what? Two equations, two variables. Are you guys with me in algebra? How could we, find the solutions? We wanted to do what? Get rid of x2 or get rid of x3. Are you guys with me? So look at this question here. What will we do first? What will we do first? Because when you see 2, negative 8, 8, for the equation, they all have what? 2 in common. 2 in common, what could we do? We can divide by 2 for the entire equation, yeah? So equation 2 times a half and give you this new equation. Yeah, so then what will be the corresponding matrix? What do you think will be the corresponding matrix? So 2 will become what? 1. Here will be what? Negative 4 and 4. Are you with me? So we will do the same. 1, negative 4, 4. Why do we want to do this? Because what do we really want? We wanted here to be 1. Remember, 1 means what? 1 times x2. Are you with me? 1 times x2. And then, it will be much easier. Then, how could you get rid of x2? You wanted the equation 2 times 3 plus equation 3. Are you guys with me? This is what we learned there. And then similarly, what will be the corresponding matrix? For here, you can algebra, you get x3 equal to 3. What will be the corresponding matrix? Everybody let me know. What do you have? What is the coefficient here? 0. What will be the coefficient here? 0. What will be the coefficient here? That is 1. And what will be the number here? That will be 3. Yeah, are you with me? So because, it should be exactly the same as here. Yeah, so this is when we get this. Are you guys with me? So x3 equal to 3. Are you with me? So you guys should know. So what are the corresponding, if you know the matrix, what will be the corresponding equations? What do we have? X3 equal to 3. What will be the second equation? 0 is x1, so we know x1 is x2 minus 4, x3 equal to what? 4. What will be the first rule? X1 minus what? 2x2 plus what? X3 equal to what? 0. Now, in Linear Algebra, what do we need to do to solve for x2 and x1s? Do you guys remember? What do? We wanted what? Substitute. Yeah, so substitute what? Substitute x3 equal to 3 into 2, and you get your x2. And then substitute x2 and x3 into 1, you get your what? You substitute x3 equal to 3 into 1, you can get what? x1, x2 minus 2x2. Are you guys with me? Yeah, and when you do the substitution, what do you think we should do with the matrix? The matrix. Actually, what do you want? You wanted to get rid of the x3 here. Are you guys with me? How could you get rid of x3? This is what? Equation 3 times what? 4. Yeah, so you want 4x3, you add negative x3. You plus equation 2 will be the new equation what? 2. Are you guys with me? So this is one of the key things for the substitution back to solve the x2. Yeah, so equation 3 times 4, equation 2, go to new equation 2. Then what will be the corresponding matrix? It will be here. It will be what? What will we have? X2 equal to 16. So what will be this number go? This will go to 0, and this number will go to what? 16. And what if you substitute the equation 1 here? Equation 3 times what? Negative 1 plus equation 1 goes to the new equation 1. What will you get? You will get this, yeah? Are you with me? So what will you have? x1, negative x2. x3 is also gone. Then what will be the number? Negative 3. Are you with me? So this step, what will you get? You will get this matrix. This matrix. Are you with me? And then what will be the last step? What do we want? What do we want? x3 here is 3. And here x2 is what? 16. What is our dream? We wanted x1 equal to something. Are you with me? If you directly want x1 equal to something, what do you want to get rid of? This negative 2. Are you guys with me? So how could you get rid of this negative 2? You have x2. This is your new equation 2. This is your new equation 1. Are you guys with me? So remember, so this is x1 minus 2x2 negative 3, x2 equal to 16, x3 equal to what? 3. 3, 2, 1. Are you with me? So now how could we get rid of x2? What will we do? We wanted what? Equation 2 times 2 plus equation 1 go to equation 1. Are you with me? This means substitution. Are you guys with me? So, although it seems like, it's a big thing, but it's the substitution that we learned here. Then what will be the corresponding here? It will be what? Rule 2 times 2 plus what? Rule 1 goes to new rule 1. Are you with me? Then what do you think will be the x1? You just what? Plug in and you will get your x1. Are you guys with me? and your x1 should be x1 minus 32 equal negative 3, x1 equal to what? 29. Are you with me? So here that should be what? Finally 29. Are you guys with me? Okay. And so these are the details here. This is what we just talk about. This is the thing. X3 equal to 3 is the last row. You wanted to only have x2 on the second row. You with me? So then you wanted to get rid of this, and then you wanted to get rid of the ones that we just talk about, and then also wanted to get this. Yeah, so because what were we finally want? We only want x1, x2, x3 on the left side, and wanted the numbers on the what? Right side. This is our goal. Okay, are you guys okay? So this is a review of chord algebra and also the corresponding matrix notation that we wanted to use in what? Linear algebra. Okay, linear algebra. Okay, so you guys, can look at these things, very carefully, and you will know that, x1 equal to 29 from the matrix notation or from the substitution method that we learned. Okay. Okay, and how could we check the answers? Yeah, are you guys with me? Just plug into the equation. We have to make sure what every equation holds. Every equation holds. Yeah, we have to make sure every equation holds. Okay, so this is this thing, and when we look at the the operation that we did, are you guys with me? So what did we do? We can use what? Replacement. Means replace one row by the sum of itself or multiple of another row. Are you guys with me? When did we use replacement? Yeah. So, we have used a lot here. Row 2 times 3 plus R3 give you the new R3. Row 2, like row 2 times, this row 2 times a half goes to R2. This is called what? It's not called the replacement. This is called what? The last row. It's called scaling. And multiply all the entries in a row by a non-zero constant. And interchange two rows. Yeah, so we didn't use the interchange two rows. We will use it in next example. Interchange two rows means what? So, if you have these three equations, equation 1, equation 2, equation 3, what will you do? You put the equation 2 on the top. That means what? Equation 1 on the second. That means what? Interchange two rows. Think about this. If you interchange two equations, will this impact your final solution? No. Are you guys with me? And if you divide the same number, non-zero number, on both sides of the equation, will it change the solution? No. And if you multiply, a multiple of one equation add to the other equation, will this change the solution? No. Okay, and these are called what? Elementary operations of the linear algebra. Means so when we do the replacement, interchange, and scaling, and so it does not impact the final solution of this linear system. And this is why we call these matrices, corresponding matrices, called row equivalent matrices. We call this what? Row equivalent matrices. Okay, so because it's exactly the same. Okay, and and there are some important things. The row operations are reversible, and if the augmented two linear system are row equivalent, and then what happened? Because all these row operation does not impact the solution, so it has the same solution set. Yeah. And so then the next question we wanted to ask is the solutions of linear system. Yeah, so, if what will be the solution? So the first question, does the solution exist? Means, is the system consistent? Yeah, so if the system is consistent, is the solution unique? Because consistent can be what? One solution or infinite many solutions. You guys with me? So, sometimes unique solution is very useful in real life. Yeah, very, very useful in real life. That will be, nobody wanted too many choices, and then you cannot make the decision. Yeah. So, if your mom only wanted to take one child to dinner, but, you have 5 siblings, which one should your mom take? That will not be a good choice for the mom, yeah? If she can only afford the dinners for 2. Are you guys with me? Yeah. So, unique solution, it will be very useful in real life. Okay, in real life, most of the time. Okay. So now let's look at another example. And so, like x2 minus 4x3 equal to 8, this, what will be the augmented matrix? 0, 1, negative 4. Yeah, so you guys already know all these rules. Yeah, so but just put all the coefficients right there. 2, negative 3, 2, 1, 5, negative 8, 7, 1. Yeah, so the first 3 columns, what is this thing called? The coefficient matrix. Yeah, so do you guys remember what do we really want? We wanted the first row, you have a 1. Here you have a 1, have a 1. Or, maybe a number here, but you wanted all these things to be 0. Are you with me? So this means x1, this means x2, this means x3. Are you guys with me? So when the first number is 0 here, do you want this? If we wanted to use the matrix, we can leave it, but it does not look good. Yeah, are you guys with me? Yeah, so so this is why there is another property. It means it interchange. Okay, so we wanted the first equation, you have an x1 there. Are you with me? So we wanted to interchange. This means the first equation, second equation, we can what? Interchange the place of these 2 equations. Okay, and this is what we have here. Yeah, we do the interchange. Now we already have the 0 here. Now what do we want it to do? Eliminate the 5. Are you with me? Eliminate the 5. How could we eliminate the 5? Here we have x1, here I have x1. For the second one, you do not even have x1. Are you with me? So we wanted to use the first and the third to eliminate 5. Are you with me? So what will we do? It's what r1 times what? Negative what? 5 over 2, because then it will give you negative 5. And plus the r3, then the 5 will be gone. Are you with me? So because 2 times negative 5 over 2 plus 5, negative 5 plus 5 is what? 0. Are you with me? So this were what? x1 will be gone. Are you with me? Yeah, so this is what we do. So in order to do it, in order to make sure that the equation holds, if we do it on one variable on the x1, you have to do it for the entire equation. Yeah, so this is what we have here. Yeah, so when you do all this and all these things to the thing, yeah, so then you will be able to 0, 0, negative half to negative 2. Are you with me? And when you get here, what should you do to get rid of the negative half? Is what? R2 times a half plus R3. Are you guys with me? If you can do that, it will be this. Are you guys with me? So R2 times a half, this will be what? A half. Here will be what? Negative 2. Here will be what? 4. Are you guys with me? Then you add this number. So what do you guys get? A half, negative a half is what? 0. Negative 2 plus 2 is what? 0. 4 negative 3 over 2 is 4 is 8 over 2. So it's what? 5 over 2. Are you with me? Yes or no? Yeah, so do not forget, if you multiply something, it's multiply the entire row. Are you guys with me? So what will be the new, you wanted to multiply the entire row here. Are you with me? And then what do you have for the new R3? You have 0, 0, 0, 5 or 2. Are you with me? Before we continue, I wanted to ask you a question. Could you write the equation of the last row, the row 3 here? What is the corresponding equation? Do you guys remember? This is what? 0x1. Are you with me? 0x1 plus what? 0x2 plus 0x3. The last number is on the right side, equal to 5 over 2. What does this mean? 0 equal to what? 5 over 2. What is your conclusion? Could 0 be ever equal to 5 over 2? No. Yeah. So what do you conclude here? This means what? No solution. Yeah, so this means what? No solution, because 0 cannot be 5 over 2. Once you have all the coefficient matrix one row equal to all zeros, and then on the right side you have a number not equal to 0. This means what? No solution directly. Yeah, so no solution. Yeah, so this is give you an example of what? No solutions. So because 0 equal to 5 over 2 is never 2. And then we call this system to be what? Inconsistent. Okay, and so this is, the material that we wanted to cover for section 1.1. So please review this and register for my math lab through BBU, and we will continue to cover 1.2 on Wednesday. Thank you. See you guys on Wednesday.